So what I'm going to talk is about leading cork business throughout R&D and innovation. So first of all, it's a lead that has to close bottles like Petrus, one of the most famous wines in the world, or a regular rosé, Mateus Rosé from Portugal, which is a good wine, but is a regular one. However, the closure has to keep the quality of Mateus Rosé as the quality of Petrus. Another point is that other type of beverages must be closed with the cork stoppers. Now we are talking about sparkling wines. The very famous Veuve Clicquot bottle, and the quality of this wine must be kept properly and entirely. And Asti from Italy, actually, which is a regular spumante. So these two wines, which have completely different characteristics and different qualities, the lid must, the cork stopper basically, must keep their quality. Again, another type of beverage, very different from these first groups, which are the spirits. With the spirits, you have very different challenges that you have to ask to the cork stopper to fulfill. Then the lid called cork stopper is fighting in the market against alternative closures. And these alternative closures are here, as you can see in your left-hand side, synthetic stoppers, and in your right-hand side, the screw caps. But then within the cork stoppers, we have very different type of closures. In your left-hand side, you have the normal and natural cork. Then a natural cork, which has too much holes, and so it was colmated on their holes by cork dust. Then the third one is the twin top, where you have a body of agglomerate cork granules with two discs, one in the top and another one in the bottom, in order to make the contact with the wine. Then you have microagglomerate corks, which are nowadays, growing up in the market significantly. And then you have the bar top corks, corks used normally for spirits, which are there to close, not just completely to seal. And then the champagne or sparkling corks. So big differences, big challenges that we have to face with a cork stopper that is going to close a bottle of wine. And so when we start here to do the research and development on cork stoppers, we divide our action in 5 objectives. The first one, improve the quality of the products that we produce. The second one, improve the efficiency of the processes used to produce the closures. The third one, understand the interaction between the products and the beverages, which I do think that is very important. Then the fourth one is develop new products, and then develop new processes. Improve the quality of products. I gave you here 2 different examples. In your left-hand side, you have a cork that do not seal properly the bottle because it leaks, as you can see here. And it leaks why? Because it has a channel produced by a wormhole. And this wormhole was produced in the tree. So why? With this wormhole, we cannot have a proper sealing. So how can we deal with the situation? Now, we developed a machine that actually we patent the machine. And this machine is using chambers and individual chambers for the corks. Each cork came into a chamber. Then this part will close into the corks. And so a situation similar to this one happens. We inject from one side compressed air. Here is the cork. And if we have air coming out from the other side, if the manometer moves the needle, that means that this cork is a potential leak cork, and so will be rejected by the machine. So the machine has two channels of way out, one accept, the other one reject. So look how we improve the quality of products, separating from the ones, from the whole corks, separating the ones which do not leak. And nowadays, all natural corks are treated by this system. Improve the efficiency of the processes. I gave you another example here. So the second objective is improve the efficiency of processes, and this is the first step of the cork production process. These are cork planks that have been extracted from a tree. These cork planks, before, they were boiled in a big tank that uses 5 pallets of cork wood altogether. And then in the top, we put a compressor in order to keep the cork compressed during 1 hour with 97 in water at 97 degrees Celsius, what we call the boiling of the cork. Why we boil the cork? Because cork will receive water and like that expands. And expanding, we have the thickness enough to punch the cork. This is in your, in your right hand side, this is the right way, and nowadays, how do you do the boiling? Instead of 5 pallets of cork wood in these tanks, you just use 2 pallets of cork wood. Using 2 pallets of cork wood, you do not need to have a compressor, because these lids, these are the lids of the tank, they open and close like that. And so the cork wood inside the 2 pallets, they will not be compressed during boiling. So the water is passing through the planks much easier than in this system. Look how we can improve efficiency of the processes. Let's continue with the presentation, talking just this slide about the development and new products. So we were talking about improving previous processes. Now we will talk about developing new processes. And this new process is called NDtech. What NDtech means? Non-detectable technology. NDtech, it's a system that we have developed and we have installed in the ground to analyze cork stoppers for a compound called TCA. TCA is the trichloroanisole and is this molecule responsible for this beautiful lady making this terrible face. Why? Because the wine has a moldy taste, and this moldy taste is actually produced by TCA. So in order to solve it, we try to make the NDtech. In these 2 graphs, you can see the TCA evolution of cork stoppers in the United States. All corks that we produce are sent to the United States. They are analyzed by ETS laboratories. ETS laboratories analyze the corks and they publish the results. And these are the last graphs they published. And as you can see, from 2001 up to 19, we have a tremendous reduction of TCA, around 98% of TCA reduction, which is a tremendous number. So we are very confident about the corks that we sell. I'm going to show a video with that kind of machine. So we feather the machine individually, cork by cork, and the corks are going to be inserted in this pre-incubation system. The pre-incubation has a revolver inside, which is able to keep, which has 16 holes. So the cork comes in, is incubated, and then the revolver moves on. After being pre-incubated, the cork is inserted in an analytical chamber, and here it is analyzed. This cork has non-detectable, so no TCA. So the cork will be sent into the good conveyor. But this cork has TCA, as you can see here. And so having TCA, the cork will be separated into the bed conveyor. So it's like that we analyze TCA cork by cork. So what we have in the field is this. This is the NDtech 1.0, where we have 10 lines with 60 gas chromatography machines in there. This corresponds to an investment of 10 million euros, and we have 15 seconds per analysis. So each cork is analyzed during 15 seconds. In 2019, we were able to produce 57 million natural corks analyzed by this method. So they're called NDtech corks. We hope in 2020 produce 65 million corks in these machines. How? Improving the performance and the productivity of the machines, not touching in the time of analysis. However, 57 million corks that we saw last year was not enough. And so we developed the NDtech 2.0, which is here. And this NDtech 2.0, it's a machine that gain a lot from what we learned in the first one. So as you can see, we have a feeder, we feed the machine in a vertical way. Then we have a pre-incubation, which is bigger. Then we have the corks coming out, lots of chromatographic changes. And then the corks are going to be inserted in this lid, which is the lid of an analytical chamber. And then they are going to be analyzed, and facing the results, they are going to be rejected or accepted in a different group. NDtech corks for the high top level. But as you, if you were with attention, you could see that we are talking about 75 million corks for natural corks, so for still wines, and 5 million corks for champagne. So for still wines, we have to say, and what about the other corks? And for the other corks, we developed the Eradication Project. And with the Eradication Project, we produce in a different period of time. We have an objective of 99% not detected and 1% less than 1 nanogram per liter. Here are the results obtained with the tests, contaminated corks before treatment and corks after treatment, which fulfill completely the spec. And this treatment is in a batch treatment, so it's not individual, it's in a batch. With this machine, we have 15,000 corks per machine here, and now we have 25 corks per machine. The last slide shows you a reference. This is a reference lot, a very highly contaminated lot that we decided to put in bottles. And after 6 months, we analyze for TCA. And as you can see, we have 6 bottles highly contaminated. With this lot, highly contaminated lot, as I noticed to you, treated by the system, after 6 months, we just have 1 bottle with 1.1, which is probably almost not detectable. And more, the number of samples here, the bottles searched here for TCA were more than the double of this here. So the Eradication Project will bring us into a situation of guaranteeing not detected TCA in 99% of the corks, which is a tremendous improvement for the future.